I was given a line segment, and I'm going to call this line segment 1. I aim to construct a quadrilateral called a trapezoid using just a line segments of 1 and circles with radius 1. So what I want to do is first construct the equilateral triangle, and the first thing I want to do is I want to construct the first circle. So I measure out, I use my compass and I measure out a radius of 1 by just connecting the tip of the compass to the edges of the line segment, to the end points of the line segment, and I make my first circle. Oh no! So the center of the circle is where this is all my hands being messed up. So I'm not going to complete the full thing, but this is going to be the center of this first circle here, and I'm going to name it A. So now what I want to do is I want to connect at the edge of this circle. I want to make another circle that has the edge on the center of the first circle. So the edge of the circle is coming off of A, and it has equiradius because the center is at B. So circle B, this one right here, has the same radius of circle A, which is right here, and circle B center lies on the edge of on the circle of A, and circle A's center lies on circle B. So what I want to do is I want to connect the radius, the center of the circle B, to the edge of the circle B where circle B and A intersect. If I'm at the center of the circle, and I go from one point, and then I go to one point of the circle, then this line is the same length as the radius because it is the radius. And I want to do the same thing from point A, and it is the same radius as point A, which point A and point B, circle A and circle B share the same radius. It's a little poor because my hands are shaky. There we go. Okay, now I have an equilateral triangle because this side is equal to this side because they're both the radius. This is the radius of B, which is the same as the radius of A, and this side is just the radius for both of them. All the angles are equal to 60 degrees due to the properties of an equilateral triangle. 60 degrees. All right. In order to construct my trapezoid, I basically want to make the same construction with the same radius. So I don't change my compass from where, but I want to draw a line from A to the edge of A. I wish I need to complete this a little bit more. Complete this a little bit more. A little bit more. It may have changed because I'm just dragging. Okay, so I want to complete this a little bit more so I can draw a line that just I want to extend the line segment that I was given to touch the edge of circle A. And this is also has the same radius because it is a radius because it's a line drawn from the center of circle A. So what I want to do is I want to create another circle. See, I didn't connect it all the way. I want to draw another circle that has the same radius as A and B, and whose center is on circle is whose center it lies on circle A, just as circle B does. And I want to do the same thing as and construct a second equilateral triangle by connecting 2 points where the circles intersect. Now we've successfully constructed 2 equilateral triangles and 1 line segment of size 2 radii, so 2r. Also, what we've done is, what we can do is to complete our trapezoid is connect the 2 ends of the triangle at the top of the circles, and this is going to be equal to this, and I'll show you and I'll tell you why. There's a theorem in our book that says that if I had completed the circle and these would intersect more, these would intersect, and you would be able to make another triangle that's an equilateral triangle, and that if I connect the 2 tips of the equilateral triangles, it will bisect this line segment. Also, if I could say this has side angle side, because this is also 60 degrees. They share side angle side shares 2 sides and an angle with this triangle, with the other, because this side is also 60 degrees, because because this is a straight line, 60 times 60 is 3, therefore we have an angle here that is also 60 degrees, and then there's one here that's 60 degrees. 60. But I was going to say that this would have been 1/2. This would have been 1/2, and this, I could have done the same thing on the other side and had half this line segment, and then this would have been 2. But since we have side angle side, we don't need to do that, and we could just call this, say they're similar triangles, and connecting these 2 will make this 1, since these have congruent sides. All right. So now these are 60, and these are 60 due to this being an equivalent triangle to those, because they share sides and they share angles. Now I have to prove to you that I've proved that this is this has a side of 1, and since this is 2 times r and our radius is 1, this is also the radius of circle, so this side is 1/2 our radius. So given x, this side is 2x. Or, well, given r, really, this side is 2r. Let me say that. That's better. This side is 2r, because we have a radius that is equal to 1. R is equal to 1. Due to this being 60 degrees, the sum of these interior angles up here is 120. And the sum of these interior angles is 120. The sum of these is 180, which is just added because this is a straight line. And these are clearly just 60. And there we go. We've completed a trapezoid. We've created a trapezoid with one side of the trapezoid being 2 times, well, 1/2 the larger side. And we also have 2 angles of 120 degrees as these angles here. So these are congruent, and then these are congruent. Thank you. That's all.